Hello everyone and welcome to Augmatic. Today we are introducing our smart washroom monitoring system, an intelligent solution designed for continuous monitoring of washroom conditions, occupancy and connected sensor device while providing both local and remote monitoring capabilities. The system is designed around a central gateway that communicates with the wireless sensor nodes installed in individual water closets or washroom areas. Each slave node continuously collects imports information from its respective washroom. This includes parameters such as ammonia, hydrogen sulfide, occupancy, people count, battery status, and device communication status. The slave node communicates with the main gateway using a Bluetooth, allowing multiple washroom locations to be monitored wirelessly from a single central unit. But the system is not limited to sending information back to the gateway. Each slave also provides a local visualization and audible indication, such as LEDs that can indicate current conditions of monitored environment, such as green, yellow, and red indications. The green represents good condition, yellow represents warning conditions, and red represents a required attention condition. An audio buzzer can also be used when a poor condition is detected, providing an immediate local alert without requiring someone to continuously watch the monitoring display. At the center of a system is a Vitalvi Smart Washroom Monitoring Management Gateway, featuring a touchscreen interface that provides a direct access to a complete monitoring and configuration system. When a gateway starts, it presents the Augmatic startup screen, followed by the main home screen. From the home screen, as you can see, there are multiple menus: dashboard, pad device, live data, and reset washroom data. The dashboard provides a communication network and configuration system. Inside the dashboard, the operation can access the MQTT dashboard, Wi-Fi setting, and MQTT setup. The Wi-Fi setting provide information about the current network connection and include a connected SSID IP address and signal strength. Now, the MQTT dashboard shows whether the gateway is connected to the MQTT broker that configured the broker address, publication topic at the time since the last published message. Through MQTT setup, the gateway can publish and collect the washroom information to a remote IoT platform or a monitoring application, allowing the data to be accessed beyond the physical location of a washroom. The MQTT setup can also be configured directly from the touchscreen. The operator can set the broker address, port, username, password, and MQTT topic and save the configuration directly from the device. The second major section is a pad device. This section manages the Bluetooth sensor node connected to the gateway. The operator can scan for available sensor devices, pad nodes, and view the devices that are currently paired with the system. For example, the device such as NRF washroom can be paired with the gateway and assigned as a monitoring washroom sensor node. If you want to add a new device, you can go on the new pad device settings, and on the new pad device settings, in here you can see multiple sensors and you can tap on it to connect the sensors. Once the device is connected, its information becomes available through a live data section. The live data screen provides a complete overview of a connected washroom. For each device, the gateway can display the current NH3 levels, H2S levels, occupancy condition, people count, battery level, and communication status. This allows the operator to understand the condition of a washroom at a glance. For example, the display can show whether the washroom is occupied, how many people have been detected, the current gas readings, and the remaining battery levels of a wireless node, whether the device is online. As more wireless sensor nodes are installed, the same gateway can manage multiple washrooms and provide their information through the same interface. The system provides a range setting option for individual washroom devices. By selecting the slave, it allows operator to select a particular sensor node and configure its sensing range using a plus and minus controls before saving the required values. The system also includes a reset washroom data for maintenance and counter management. From the reset counter section, the operator can select particular washroom and resets its accumulated values. Before performing the reset, the system displays a confirmation message to prevent accidental operation. Once confirmed, the selected washrooms people count, NH3 and H2S counters can be reset. This allows the monitoring system to be configured according to the physical installation and requirement of each washroom. So when we look at the complete system, the operation is completely straightforward. The slave sensor node monitors the individual washroom. They communicate with the central gateway with the Bluetooth. The gateway collects and displays the information through its touchscreen interface. At the same time, the slave node can provide immediate LED and buzzer based location alerts when the monitoring conditions reach a configured warning or a critical level. The Wi-Fi gateway also connects to the network and can publish the collected information through MQTT, making the data available to a remote monitoring system and IoT applications. This creates a couple of monitoring chain from a physical washroom and its sensors to a wireless slave node to a local gateway and finally to a remote MQTT based monitoring platform. The objective of the smart washroom monitoring system is to make washroom management more intelligent, more connected, and easier to monitor. Instead of depending entirely on the periodic manual inspection, facilities operations can have continuous information about the condition, occupancy, connectivity of the monitored washroom. With a wireless sensor node, local visual and audible alerts, touchscreen based management, Wi-Fi connectivity, and MQTT communications, the system provides a flexible platform for a modern smart washroom applications. This is the Vittelby Smart Washroom Monitoring System by Hyginic Technologies, bringing sensing, wireless communication, local monitoring, and IoT connectivity together in one intelligent solution. Thank you so much for watching and stay tuned for more innovation from Hyginic.